All right. I think we're live. Looks good to me. Cool. So I wanted to go over sort of what I have been working on for, I guess, the past week. And I guess sort of talk about what I have maybe worked on, what I've discovered in the ways of, oh, beautiful. Okay. In the ways of AI, because there's a lot of really interesting things out there, but I've learned that there's also a lot of misleading information, confusing information. So maybe it'd help to sort of go through some of the notes that I've been taking in this space. So I have been in a number of discords, and there was a interesting talk from the I think founder or someone, CTO of Glean. Glean is a enterprise. It's a Glean work. They're an enterprise search, and what I found to be the most interesting about Glean was in talking to, or not talking, but listening to the fireside chat from him, was they care a lot about accuracy of results. So that makes a lot of sense. And because it's like you work at an enterprise, and imagine an AI hallucinating and saying that, like, no, Tammy is not in charge of HR. She actually has the nuclear launch codes. I don't know. Like, you can imagine all sorts of bad things that could happen if you let an LLM hallucinate for a company search. So I was listening to him. He had a lot of interesting things to say. I have some chicken scroll notes here, but one of the things that I found interesting, and these were new terms to me, but the difference between sparse and dense indexes. So this is something that words I've obviously heard before, but seeing them sort of talked about from his perspective as someone that runs like a AI search ML search company. A sparse index, to my understanding, is talking about like vectors and like, I guess, searching through a search space that's not necessarily representative of the immediate information, but more representative of the relationships that information have between each other. So I've been reading through this. This is a really cool manual, by the way, or a book by Pinecone, online book. You can go and read it. It's the introduction to Facebook's AI similarity search, Face. I would love if someone could tell me how to actually pronounce this. Face. So Face is pretty cool. It is open source, and it does similarity searching. And to my best of my understanding, this is a sparse search because it creates vectors, and the space, or the way that you search for things, and there's a great diagram here, is all of your content ends up in what's called Voronoi cells, and centroids are the center of that. And so when you go to search for something, you take your query, whatever you're searching for, and you try to turn it into a vector that points to someplace in this sparse space, because these blocks are not representative, or these cells are not representative of like volume of data, right? Because if one cell's bigger than another, it's not necessarily means there's more information. It means that maybe the relationships are loosely held in that cell. It's kind of unclear, right? We don't really get to see and debug. It's hard to debug this, how these form. But what is important to know is that it's sparse. There's so many documents that are inside of this cell, and when you query, you're saying, okay, this is where my query is in this space. Show me everything that's close to it. And what Feist will do, it will help you sort of find all of these centroids that are close to that, and help you sort of find documents that might be relevant. And I believe nprobe searching the single closest cell when nprobe is equal to 1 left, right? I don't see a left and right, but yeah, you can change the algorithm so that it returns so many other results as a result, but that's sparse space. Now, dense space or a dense index is something that searching algorithms normally are using. They're taking your query and they're looking directly at the content there. So they're going from what you've sent. Typically, right, canonically, we think of this as like a keyword search. You take a keyword and then you basically just go through all the content. You try to match where does this word absolutely, or maybe slightly fuzzy, right? Fuzzy match on this content that I'm searching over. So if you've written a database, you go through every single row, or maybe you've created an index off of n-grams, but this is called a dense index because there isn't space in between the content. It's dense in the sense that you're just going over all content, trying to find it. So it's been interesting to think about. And what the guy from Glean was talking about was the fact that the dense search algorithm BM25, which I believe Google best matching 25. Oh no, that's been around for a while. So I guess it's been around for a while, but the guy from Glean, he was talking about how this is an algorithm that's still relevant. It's still performing really well. And when people do research of BM25 versus vector searching, this still performs pretty well. So it was actually kind of funny because I had seen someone write code, this project, Garev. I'm going to butcher the pronunciation on this, but in my head I say G-Rev. But anyway, this is an open source searching tool that is pretty slick. You add your different sources of data. So I think what does it support? Like Confluence, Slack, Drive, Bookstack, Mattermost, Rocket Chat, more to come. And it was funny because I joined their Discord and I talked to the guy that runs this, because what I was wondering is how they ended up on these two indexes. So FICE, like I just showed, this is a sparse index. It's using vectors to search, right? And kind of like they go off this way. You try to find the one that's close, pick those. And then this is searching dense space. This is a dense index, BM25. This is something that we're akin to knowing about. It's like a ranking, more of a ranking algorithm rather than like trying to find nearest neighbors. So I had noticed this, and right after listening to the Glean guy, I put two and two together of like, where have I seen this before? Oh, right, they've done this. And so I asked the creator of this app, like, have you read something? Are you experienced in the searching space? And he said, no, actually we had realized is that we originally had this vector search, but it wasn't performant enough. And so what we ended up adding was this BM25 index to produce better results. And it was. Now, what's even more interesting about this, which is pretty cool, and is it in this file? What is it? It was a file search logic. Yeah, so the search logic is pretty interesting. Let's zoom in here. So search logic employs a cross encoder. Now, this is slightly beyond my knowledge right now, but what I'm looking at in this code when they do a search over the documents is they're looking for results from their FICE index. They are looking for results from their BM25 index. And then from the candidates that they find, they cross encode them using those candidates that they found from using the two different searching algorithms. And then they try to, I guess, calculate the one that's most relevant from those results. So again, this is not something that I'm too familiar with. I'm trying to figure out what's going on here, but to the best of my knowledge, it's just trying to find the results given the two searching algorithms, which one of those candidates that have been found, searched for candidates, is the most relevant. And that seems like a really interesting idea. It seems super simple. And this line of thinking had got me wonder, like, oh, are there more general purpose searching tools, like things that help you build out these search indexes? And the thing that initially drew me to Llama Index originally is that it seemed like there's a lot of really good ideas here. Now there's a lot more focus on LLMs, so the large language models like OpenAI versus the specific algorithms such as FAISS or BM25. But the ideas here, in my opinion, are really, really sound, especially when it comes to composition. Where are you? Index structures, composability. And I mentioned this in a previous video about using Llama Index, but I really like it. And it helped hearing what the guy from Glean had said, in addition to seeing some other things in practice. It seems like composition and being able to combine multiple different techniques together is going to be the thing that makes you profit in this space ultimately, because there's just so many different types of information, and the availability of data versus the queries that you might want to ask are going to be different. I think things like agents are going to add a lot of value here, because agents are kind of going to act as the catch-all, right? Or maybe the zeroing in of, I can't interpret what you're saying, go get me some data, maybe I can help you. Or, you know what, I really know what I want here, I'm going to go get some data. But the index for building it for different sizes, types of data, that's going to be really important here, I think. And so I have been thinking a lot in this space, and there is a company that I came across, Haystack, which I would highly recommend you checking out. They have amazing tutorials, but the developer of Grev, I'm going to call it Grev. I'm sorry if I'm mispronouncing it, but Grev, the author, he had known about Haystack, and he rightfully stated that Haystack is not necessarily doing state of the art right now. This company has been around for, some time, and they have a lot of really cool documentation. But as I have mentioned so far, and you'll see right on their docs page, they have this, the state of the art is valuable. There is a lot of really cool things happening in this space, but it's important to remember why some of these algorithms have existed in the first place. And to the best of my knowledge, they're not obsolete yet. They still have a lot of relevance. And where I see they can actually be really, really powerful is, right, for understanding when you understand your data and you know that this algorithm, BM25, is going to be effective on it, you can then really, really quickly, because speed is also another parameter here to consider when you're doing search, and you want things to happen really fast. BM25, that's going to be faster than almost every vector search, to my understanding. I could be wrong, but that's going to happen fast, and it's simple, and it's going to give you some pretty good results. And then you can throw that into the context of an LLM, and then using something like LangChain's Refine, you can arrive at a meaningful answer probably pretty quickly, and it's going to be pretty high quality. And there was another really interesting point in the Fireside chat that caught my attention, and that's that Sam Altman had said that LLMs should be treated more like a reasoning engine than a knowledge base, if that makes sense. It's good at transforming ideas and transforming content rather than it itself knowing what to do and then just sort of doing it. So if you put the relevant context in front of an LLM, it's going to perform pretty well because it has everything available to it to sort of reason about it, right? You kind of have put everything out on the table, and now the LLM can just do the last mile of reasoning about this stuff. Now, still probably prone to hallucinations, but I think you can get pretty good results by using that. So that's sort of the path that I've been thinking about. But Haystack is a really, really cool project. Somewhere in there, the tutorials have a lot of different things. They focus a lot on the pipeline, which is pretty cool. And pipelines are really, really powerful because you can take in a bunch of information, and they have things like an Elasticsearch document store. So Elasticsearch, tried and true. This thing's been around forever, and it works, right? It just kind of works. And so if you're unsure, you're trying to build a search and you're unsure where to start, like, I think Haystack's going to get you pretty far, you know? It's going to be pretty performant, and it seems like they have their eyes on LLMs too. Like, I believe so they have that integrated inside of there. So, you know, you can build your pipeline, you can test it locally using things that aren't necessarily state of the art, and then you can probably slowly introduce these newer concepts as they mature, right? Because again, I don't know about you, but it seems like there's a lot that's still up in the air about where this stuff could go. So I think, you know, sort of playing with what's tried and true, if you really want to seriously push on, like, you know, building a search, building a chat, data is going to be really important. So you want to try to make a really solid pipeline that collects data. And then, you know, that last mile where you're just sort of like editing things and you're trying to reason about this data you have on hand, that's where the LLMs are really, really going to shine. So yeah, that's Haystack. I think it's really cool. This Feist book, really, really nice. I started putting together this wiki. It's really, really bare bones right now, but what I'm hoping to sort of do is capture all of these different places that I'm consuming information, things that I learn about, capturing them here. And again, it's all open source, so you can also make contributions to this wiki where you find information that's relevant. But these are some of the Discords that I'm in. There's more that I can add now. They're fantastic. There's a lot of really, really smart people there. I highly recommend, you know, if you're interested, joining those. And then, of course, there's always Hacker News. So let's see if this is actually working. Do I have it running? Because speaking of Hacker News, we got something cool that's brewing. So it doesn't look pretty, but what this is right now is I have it set up to pull down. So this is Lunabrain. I'm showing Lunabrain. And Lunabrain is collecting the front page articles from Hacker News. It is pulling down all the content, right? So it's doing a HTML curl, but it also has, actually, I think this is not curl. This is like loading it in the browser, in like a headless Chrome browser. So like Selenium scraping. So it loads all the HTML as it would exist, as if, you know, I'm viewing it. It cleans it. I'm still skeptical about the usefulness of this, but it extracts the relevant article from there, and then it uses a LangChain summary. So this is like OpenAI sort of recursively going over, or iteratively going over this article and saying, based off of this context, or based off the summary, you know, adjust it as you see fit. The prompt is somewhere in there in LangChain. You can find it. But this summarizes it. And it also, I integrated a model that categorizes the content. So I believe based off of the summary, we get a list of tags that are relevant to it. So in this one, and this is going to need to take some tweaking because engineering, science, code, like, okay, that's pretty broad. But there definitely are categories. Yeah, like reading book recommendation books. And then we look at the summary in her book. Cool. Like, that's talking about a book. Reasonable that the category is book. What else we got here? Categories, cybersecurity. SIM provides a streamlined and efficient solution for granting, revoking, managing access. Boom. You know, I feel like that nailed it. Learning AI, like, and then boom, AI. I think like, I've just kind of thrown this together, you know, I am not really thinking about this, but the preliminary results for what I'm seeing here, if I like kind of clean up this interface, like, I feel like this is something that I would legitimately use. You know, like, I go to Hacker News, And I see these titles, sometimes they're clickbait. Like I always joke like with my friends that it's like, oh, you know how you get to the top of Hacker News is you write the lightweight portable CLI that runs on everything, or written in Rust. So a little bit of clickbait. But what I find interesting is that if you were to view Hacker News through the lens of like some summary, maybe it has hallucinations, maybe it gets the summary wrong. But this is actually what the content is. So if you're interested in more long form content, like blog posts and stuff like that, I feel like a summary is going to kind of nail your interest. It's kind of like more reading like a tweet. I think I set this. No, I don't think this is 150 characters. That looks like more. But I was trying to make it the size of a tweet. So it's like you could view Hacker News as if all of the front page articles were tweets. And then you also have the additional ability to look at specific categories. So if content shows up on Hacker News that's related to AI, it'd be cool, to get a notification about like, hey, there's this new thing on the front page that's talking about AI. And boom, you're right there. You're looking at that content, you're staying on top of it. It has a hard time with certain things here. So this is like way too broad. That makes no sense. Yeah, so we're definitely going to need to train it a bit. But what I'm also kind of hoping is that as I add more features, I hopefully we'll have be able to implement a feedback system here relatively soon. So if I'm reading this, the article provides an overview of working with strings. So I would probably say like this is more programming than it is just like software. I might say like, yeah, code might be more relevant. Attack vector. So this also seems like security. I don't know. But anyway, there's so much to do with like ML, like in content parsing. And I found just hooking up these random models to be like really encouraging and really fun. So I kind of see this as like a playground as well of like, you just kind of toss in to like this Python thing. I want to now, I don't know, what's a crazy ML model? So I'll go like Hugging Face, tag. This is the model that I'm using, T5 based tag generation. You can go to models. Let's find one. What do we want to do? Video classification, text generation. Oh, there was this cool one. Question generator. Now this one's really interesting. So you have this model, this runs, takes in some content, and when you run that content through the model, it will generate a question that you could use this content to answer. Now, that's really interesting because one of the problems with search, use the semantic similarity, is that you start with a question, someone starts with a question, and the content doesn't have usually questions in it, right? The content is a blog post. It's just straight content. It's synthesized content, not necessarily from the question of, or from the point of like question answer. It's more just straight content. But if you can turn arbitrary content into a question answer FAQ style like organization, your queries can perform, I think, pretty well theoretically, because what you're now looking for is just where has this question been asked in the content? What content has this question associated with it? You can index based off of questions versus off of the content itself. So maybe that might help. There was another technique that I saw called, what is it? Hypothetical. Yeah, so HIDE. Hypothetical document embeddings. Now, this is another, right, sort of crazy technique here, or crazy genius, crazy period. I don't know. Who knows yet? It generates So it takes a question, right? What did Paul Graham do after going to RISD? And it generates a hypothetical answer to that question. So is it going to show that you have to go to the notebook? So a theoretical answer to this is, what did he do after going to RISD? He went to Disneyland, right? Paul Graham went to Disneyland. Disneyland is a place. Why couldn't he have done that? So it's hypothetical. Now, I think that there is, because the LLM, so this is using the LLM to generate it, because the LLM is like pretty smart, more smart than saying that he just went to Disney World. He probably went to, you know, some college, or he went to some company, something like that, right? He did something that's relevant to who Paul Graham was. Paul Graham's a well-known person. So because it generated this hypothetical answer, and that hypothetical answer is something that is probably close, you know, to being the right answer, when you do a similarity search, yeah, so I think one of these is made up and maybe one of them's the answer, or maybe they're both the answer. But anyway, because the hypothetical answer is probably in similar form to whatever form that you have that data stored as, because the answer is going to look in the form Paul Graham went to blank after he went to RISD. That's if you have that answer in your content, it's probably going to look something like that. So if you have the hypothetical document and then you search through all of your documents for something that looks more like in the form, I guess is how I mentally think of it, what's in the form of this hypothetical document, then theoretically you could pull out the answer relatively easily and you could get pretty good results. Now, in this notebook, there are like failure cases, like high may mislead, when query can be misinterpreted without context. So, right, if you ask a general question, it's like it has no idea what's going on, and so it could just like completely make something up. Because Bell very well could be a programming language. Is that true? Oh my God, I don't even know what's real. What's real, what's fake? I don't know. Hey, may bias open-ended queries. What would the author say about art versus engineering? Yeah, so it's like, right, you establish like some opinion, but that opinion's like so specific that you can't actually, because it's something more nuanced, it's hard to actually pinpoint exactly what the answer is. But obviously Hyde's not a silver bullet, but it's an interesting technique. And like I said before, if you have this pipeline and you can kind of play with these different techniques and you can do that really quickly and you can A/B test that, like, I think you're really cooking, you know, you can get something that's giving you pretty interesting results. Like, is it going to be perfect? I don't know, but I think a lot of people right now are waiting around for fine tuning to come around, because I think people think fine tuning is going to solve a lot of problems. And I don't know. I'm not an expert. I can't say if it will, if it won't. But what I do know is that your ML period is only as good as your data, right? If you're fine tuning a model, it's the data in, right? It's the data that you have that you can put and then fine tune that model. If that even is the most trivial process in the world, you run a Python script. If you don't have the data, you don't have the model. You don't have the fine tuned model. So what I've been thinking a lot on is just building, you know, this solid pipeline. You have this pipeline of data. Maybe it doesn't even do anything state of the art. You know, I really like what Haystack has going for it, and just build on top of there, right? Don't try to do the complicated thing first. If you're trying to do an AI money grab and say that you are, you know, built on top of GPT, and so you're just using OpenAI's API, you know, good for you. I think you might do really well. You might raise enough funding to last you. And I think that's just something fundamentally that I differ. Like, using OpenAPI is like a nice that it exists. It's a motivating example of what could be. but I've just sort of seen too many hallucinations with it that I kind of want to stay closer to the ground truth. And listening to, man, I needed Eddie. Is it Eddie from Glean? I think it's Eddie. Listening to Eddie talk, it was really affirming because it's like, yes, like you do sort of need this pipeline. You need to play with different techniques. And I think they said that they did roll out an OpenAI integration into their stuff. So, and that's been giving some good results. So, you know, we're all here. We're still just trying to figure out what works, what doesn't. And, you know, there's a ton of resources. I've been just clicking through so many links, and it's been really cool to learn everything so far. So, you know, we're going to keep going. We're going to keep looking at stuff. And yeah, until next time, I'm going to be researching. So I'll see y'all later.